In this video, we're going to take a look at the so-called laws of exponents. Okay, so recall that we're talking about some base, and we raise it to some power. This is the notation. This is exponential notation. This is referred to as a base, and this is referred to as the exponent. Now, an exponent is just a way of, it's sort of shorthand, raising things to powers. Let's use a numerical situation. If I have 2 to the third power, what does that mean? That means I'm taking 2 times 2 times 2. I do this 3 times here. Okay, so this is the exponent, what it means. So 2 times 2 is 4 times 2 is 8. So 2 to the third power is equal to 8. To do that on a calculator, 2, and then if you have a TI calculator, TIs have this up arrow, this caret. That means raising it to a power. So that's 2 raised to the third power, and that gives us 8. Okay. And a note on doing calculator work with exponents. What if I had negative 2 squared? Well, let's do that on the calculator first. Negative 2 squared. And we get negative 4. And you might be scratching your head and saying, wait a minute, we got a negative times a negative, isn't that a positive? We get into how the calculator thinks a little bit here, and this is really why I mention this, because this is important. When a calculator sees an expression like this, it's got a negative in front of this base. Well, first of all, its primary rule in dealing with exponents, and this is the same way you think of it with pencil and paper, this exponent applies only to this number. Now this has a negative in here, and we may be implying by this that we want to do a negative 2 times a negative 2. And we know that a negative times a negative is a positive. So why isn't the calculator giving us that? Because it breaks this apart. It says this is a negative 1 times 2 squared. That's how it thinks. And because of the order of operations, where we have to do exponents before we do multiplying, it raises this 2 to the power of 2, which gives it 4, and then multiplies it by this minus 1, and gives us negative 4. So when you're working on your calculator, and you're raising negative numbers, and the implication here is that this is what you want to do, then put it in a calculator that way. Okay, so now if I do a negative 2 inside parentheses, and I raise that to the second power, I'm going to get the answer that I would expect, a positive 4. You really only need to worry about this if you have even numbers, if your exponent is an even number. If you have an odd number, it's not going to matter much. Okay, but you should get in the habit of doing that. Put it in the calculator how you mean it. Use signs of grouping. Okay, that's parentheses and brackets and so forth. Okay, so let's get to the laws of exponents. Any number raised to the 0 power is 1. It doesn't matter what it is. If I have 65,535 raised to the 0 power, it's equal to 1. So anything raised to the 0 power is 1. Anything raised to the first power is just itself. Now, why do we even include that? This seems to be pretty self-evident. Well, it's that darned invisible 1. It gets, it's like it was up here. It was an invisible -1 that's in front of this 2. It comes in all over the place, particularly in the next law here. If I have a to the m power times a to the n power, notice I have the same base here. This is a to the m plus n. That's why this is an important rule, because if I have 2a times 3a to the third, what is that? Well, 2 times 3 is 6, and this is a times a, and the exponents add. There's a 1 here, so this is a to the 4th. That's a common mistake made by beginning algebra students. They forget that invisible 1. So keep track of that. And if we have a to the m divided by a to the n, then the exponents subtract. Let's see, what else do we have? Well, if I've got a divided by b, and I raise that to the m power, that's the same as a to the m, b to the m. So we can split these apart, or if I have something like this, I can put it inside. What if I raise a power to a power? I've got a to the m, and this is being raised to the nth power. Now we get a to the m times n power. When you raise a power to a power, the exponents multiply. Let's see, probably the last thing worth covering here, well, 2 more items. A to the minus m, I have a negative exponent. That means that whatever this is, whatever the base is in a denominator, and it's raised to what this power is. If there's some other number up here, like if I had 3 a to the minus m, this is the same as 3 over a to the m power. Okay, so any number up here multiplying our base just stays in the numerator. And I guess the last thing worth mentioning, if I have a fractional exponent, a to the m divided by n, it's power over root. Power over root. What do I mean? Well, that's a, and it's going to get a radical symbol. This is the power m, and this is the root. So if I had a to the 2/3 power, that's a cubed no, I got that right backwards. 3, 2. That's a squared to the third root of a squared. Got to remember the powers over the root. I keep that in my roots are on the bottom, grow in the ground. That's how I keep that straight. Okay. So just be careful how you enter this stuff in a calculator. You can let it do the work. This calculator does not have a fraction key on it. Most of the modern calculators do. I run the Linux operating system, and I don't have a nice Casio scientific calculator emulator like I do in the Windows world. This TI-83 has been around for 100 years. But you can do, just put your stuff in, if I had 8 and I want to raise it, TI likes to use this up arrow key here to raise to a power. If I wanted to raise that to the 1/3 power, put any fractions you get in parentheses. So there I'm raising 8 to the 1/3 power. That's basically the cubed root of 8. I think that's 2. Yeah, it is. Okay. So power over root. Okay, that's a pretty quick introduction to the laws of exponents. So you might want to review that. This is going to come in. We're going to be dealing with exponents in the video covering decibels.